Now in this topic, we people are going to study about the effects of the rotation of the earth. Okay, effects. Now let us start with the effect number one. Okay, as we have already discussed that this is earth, dear student. Okay, and if the sunlight has to fall, it will fall on the place where I have written 1, but sunlight cannot travel this way here. Now it cannot travel this way, so here it is going to be the night. Okay, so rotation of the earth causes alteration of days and night. Now remember this part. Okay, now earth, you know already that earth rotates around itself, rotates. That means after some time this part will now come in front of the sun and it will receive more light. Therefore there will be day and this part will go behind, so there will be the night time. Okay, so this is simple to understand. Now this is a very clear picture. Okay, the sunlight falling on this part, so there is going to be day. The sunlight won't fall here, so this is going to be the night, and this is that tilted axis of the earth. Now second important point, dear students, that this rotation of the earth is also responsible for variation in time. Okay, in second chapter you have already studied that whenever any part of the earth that comes in front of the sun, okay, it is experiencing 12 o'clock time, that is it is the noon over there. Okay, for example, while moving around the earth, let us say this meridian is exactly in front of the sun, suppose this, so here it will be 12 o'clock. So when earth will move towards this side, so then this meridian will come in front of the sun. Now so then here will be 12 o'clock. So when earth moves further, then another meridian will come in front of the sun. And in this way the time on earth will also go on changing. So in very simple words, earth's rotation is responsible for variation in time on earth. Okay, dear students, now the next effect is that earth rotates from west to east. Sorry, earth rotates from west to east, and therefore the planets, stars, sun, moon, they appear to move from east to west. It is exactly like what? That if your train is traveling in this direction, you will find the objects here moving in opposite direction. So your train moves this way, you find the objects moving exactly in opposite direction. This is what we can conclude, that if the sun and moon are appear to be moving from east to west, that means rotation of the earth is taking place from west to east. So rotation of the earth is therefore responsible for the movement of planets, apparent movement of the planets from east to west. They are also responsible for sunrise and sunset, moon rise and moon set. Okay, moon rise and moon set are similar to sunrise and sunset. Okay, moon also rises and moon also sets. So rotation is responsible for that apparent movement of the heavenly bodies from east to west. Then dear students, we have, okay, the earth rotates from west to east. So as I already told you, okay, these stars, we call them by the name heavenly bodies. Okay, heavenly bodies simply means sun, star, moons, okay, any celestial object that is seen in the sky. Okay, asteroids, comets, all of them are together called as heavenly bodies. Okay, now next important point, dear student, which is very important, that rotation of the earth has given rise to a force called Coriolis force. Now what happens because of this Coriolis force? Now please understand, this is a very important thing. Suppose this is equator, dear students, and if the wind is going to blow in straight direction in the northern hemisphere, it appears to move. That means it not appear, it actually turns or bending towards the right hand side in the northern hemisphere, whereas in southern hemisphere the body is moving straight, like ocean currents, wind, they deflect towards the left side. So please remember, Coriolis force is a force experienced on earth because of rotation. What does that force do? That force is responsible for forcing the winds and ocean currents moving in the northern hemisphere in a straight line to get deflected towards the right side, and in the southern hemisphere deflected to their left side. This law, which tells us that ocean currents and wind are going to deflect towards the right side in northern hemisphere and towards the left side in the southern hemisphere, the name of this law is Farrell's law. Okay, what is Farrell's law? This is a law that tells us that ocean currents and winds moving in the northern hemisphere in a straight path will get deflected towards the right, and the same ocean currents and wind in the southern hemisphere while moving in a straight path will be deflected towards their left side. Okay, towards their left side. This law is called as Farrell's law, and the force which is responsible for this movement, I'm talking about the deflection of the wind and ocean current. The name of the force which is causing that deflection, name of that force is Coriolis force. Okay, Coriolis force is found in a body which is rotating around itself. So rotation of the earth in this way is responsible for Coriolis force, which is responsible for deflection of ocean currents and wind. Now please understand, now if equator is this and if this is the motion of the wind in a northern hemisphere, the wind will be turning towards right in the northern hemisphere, and in the southern hemisphere it will be turning towards left. Now if you look at this cyclone, dear student, okay, because it is in a northern hemisphere, so instead of moving straight, this cyclone will be starting moving towards the right hand side, and to whichever part of the earth it will go, it will cause change in atmospheric condition. Now in southern hemisphere we have seen, if this is the original path, the things will bend towards their left. Okay, so this cyclone, instead of moving this way, will start moving towards the western coast of South America continent and will cause change in atmospheric pressure at those places. So cyclones too get deflected and change their path, and wherever they reach, they will cause over there change in pressure conditions. Then dear students, we have another effect. Okay, now if you take dough in your hand, DOUGH, dough. Okay, now this dough, dear student, please understand what I'm telling you now. Okay, this dough is made from taking the flour. Which flour? You may take wheat flour, and you put water into that one and you carry out the kneading of that one. And once you take that dough in your hand, dear student, okay, what will happen? That when you take it and start moving it, okay, you must have seen your mommy making chapati, so she start rotating it, and when she start rotating it, you will find it start getting flattened like this. In a very same way, the motion of the earth, I'm talking about the rotation, is responsible for, dear students, for the flattening of the poles and bulging at equator. Therefore, shape of the earth is not exactly spherical but slightly flat at the pole, and we call this shape by the name oblate spheroid. Oblate, okay, slightly flat at the poles and bulged at equator. Dear students, one of the very powerful forces present in the universe is gravitational force. Now, if you study physics, you will get to know that each and every object in the universe exerts a gravitational force on every other object close to it. Now here you see moon, and moon is quite big, dear students, okay? So therefore it will have substantial gravitational force. Now, whichever part of the earth is facing the moon, the water present on that side start getting pulled towards the moon. So here the high tide will start. Now, very interestingly, not only the water is getting pulled, dear student, but earth itself also get pulled towards the moon. So on other side also, here the water remains there only, whereas earth moves forward, causing high tide on other side. Anyway, right now our topic is not tide, our topic is the rotation of the earth, okay, is responsible for different places experiencing tides, okay, different places experiencing the tides. Now please understand this very important thing. Now if this is the earth, dear student, okay, and if moon is present here, so when this part will move this way, I'm talking about the earth, when earth will rotate, so when this part will move away, so the next part will come in front of the moon. So now that part will start experiencing the high tide. Please remember, the moon is present here, and let us say this is earth. When the earth start rotating, dear student, whichever part of the earth start coming in front of the moon, that part will start experiencing the high tide. I repeat, if this is the moon, dear students, and let us say my this hand is indicating the earth. So now this part is right in front of the moon. So here will be the high tide here. But when earth will rotate, and now the other part has come in front of the moon, so now this part will experience the high tide. So rotation of the earth is responsible for tides taking place at different places on earth, okay. Now the next effect of the rotation of the earth, dear student, okay, is called as centrifugal force, okay. I'm writing here the word centrifugal force. Now please remember that whenever something is in rotation, okay, when something rotates, then the things present on that rotating object experience outward force. I repeat, they experience outward force, the force which is moving away from the center. That force is called as centrifugal force, okay. Now let us look at this. Now this is a merry-go-round, and right now this merry-go-round is stationary, it's not moving, it is stationary. In your childhood, dear students, you must have seated on this, and you must have also experienced that when it starts rotating, the things start getting pulled away from the center, somewhat like this. The things which were initially stationary this way, they start moving away from the center. So center is somewhere here. So they start moving away from the center. We call that force by the name centrifugal force. Now look at this picture, dear student. If it was stationary, it would be hanging this way. But because now it is in motion, so this object will start moving away from the center. So this away going force is called as centrifugal force. So Earth's rotation is responsible for centrifugal force present on Earth. Okay. Now, when we summarize all these effects of the Earth's rotation, then we realize that rotation of the Earth causes alteration of days and night. Second effect, we understand that it causes different amount of insolation, different amount of heat, different amount of temperature at different places on Earth. The third important thing that we understand here, that it is also responsible for variation in time. Fourth thing, because the earth moves from west to east, we find celestial bodies moving from east to west. Because of rotation of the earth, the effect is on the ocean currents and on winds. When they are moving in the northern hemisphere, they get deflected to their right. When they are moving in the southern hemisphere, they are getting deflected to their left. Earth's rotation is also responsible for the poles to getting slightly flattened and equators getting slightly bulged out. Another one is centrifugal force, and finally different places will experience high tide at different places because of rotation of the earth. So these are the various effects of rotation of earth, dear student. Okay, now look at this another picture here. Okay, now this part of the earth is experiencing high tide because it is getting pulled towards the moon, and while rotating around the while revolving around the sun, dear student, sometimes the moon comes exactly in between the sun and the earth, and at that time the gravitational force of moon and sun together are responsible for very high tide. We call it by the name extreme high tide.